So, for the ones of you that are still with me, I hope you had a long break. That was the longest one you would get. So we're not doing much more, but I want you guys to explore something. I asked you yesterday by email to download and install Wireshark. And some of you hopefully did this overall. Yes? No?
Yes.
Good. Okay. Good. Wireshark is there. Right. So, few words on Wireshark before I'm, letting you loose. I probably should have put a disclaimer down there immediately, like, don't do anything stupid within this tool. The reason is, it's a network sniffer. And what it does is basically setting your network card to a so-called promiscuous mode, in which it doesn't really, well, it still sends information from the operating system, but it actually listens to all packages that are flowing over the network. That's often used for network analysis. As an administrator, you would use that to, see what your devices are actually sending, if there's malicious code on the network or activity on the network, or simply to debug devices in the first place. So in this facility, of course, we are in a shared environment. Worse of all, we're in a university environment. So I don't think we can just, sniff other people's code. So I strongly encourage you to use Wireshark wisely. Of course, only for listening, and mostly on your own network card, which I show you in a second how to set up. But then we are off on our way to use that. Note that Wireshark is passive, so it's not used. It's generally not actively used for attacks as such. But of course, that would be the next step. If you want to, try to exploit something, you would need to use other tools for that purpose. And again, don't. Right? So we are not a security class, and I don't want to spend time with all that drama about getting into some sort of legal trouble here, because we just want to understand what the TCP/IP model is about and understand the entire stack. That's why I'm suggesting to do that. Right, so if you have configured it, I'll bring up that slide in a second again, so if you haven't followed it at this stage, don't worry. I just want to run you through briefly Wireshark before I let you alone and briefly play with it on your own. So again, it's not something you will use terribly often, but it's perhaps quite helpful to analyze your traffic on a lower level than HTTP, right? For example, using Postman, it's good to observe what's happening on the HTTP level and debug REST functionality. But if you need to go lower, then this is the way to go. So if you open Wireshark, you get something like this. And the first thing you would need to do is to select the interface. Sorry? Yeah, the Windows magnifier, of course. Thank you. Good, better. Yeah, there you go. Right, so you see something down here, something like capture, that may vary a bit for different operating systems, and it offers you a set of interfaces. Those are the network interfaces that your machine has, and they will be different for your machine than they are for mine. Yeah. In this example, for example, here we see that I'm running VirtualBox, so there seems to be some traffic going on here. I have Ethernet connectivity, that's the cable-bound internet connection that I have, and Wi-Fi and Bluetooth connection. So yes, IP also works over Bluetooth connection, so it's inherently indifferent about the underlying hardware, which is quite again, good example why the layer protocol makes sense. But probably the one we are probably having a look at now is the Wi-Fi protocol, because there's some traffic going on. Oh, hang on, there's a lot of traffic going on here, but that's my stream, so I probably not listen on that. Actually, I should listen on that. Let's see what's happening there. I probably won't be able to do much more than that. So if you click on this one, what will it do? Well, it will open up, and at this stage, I need to remove the magnifier a bit to see what's actually going on. So what does it do? It basically logs all the traffic that I observe on this particular interface. And to apply my own cautious advice, the first thing you want to do is to figure out, okay, what's actually your IP address? Because you only want to actively deal with traffic that belongs to you. So what I need to do, yeah?
On the screen, the actual computer circuits is small and your camera is big.
Oh, that's ugly. Thank you. I didn't switch back. Yes, thank you. That's very helpful. Sorry, stream. So the idea is here. We need to I need to identify rather my local interface. So you can do that using the command ipconfig/all. So whoever can read ipconfig/all, I can bring up the magnifier again, and that should allow you to figure out what your current what your current IP address is. In Linux, you probably use ifconfig, interface config, to do the same thing without the all parameter at the end. And then the tricky thing is, of course, to figure out which network card is the one that you're currently interested in, right? So in my case, it would be, I think, this one here. And then you find here the IPv4 address somewhere, 128.39.142.187. In my case, it will of course be different for you. And then you can do, in this filter, you can directly type into IP address and equals equals. It will validate the input immediately, so you get some feedback. What was the 128.39, 128.39. That's it. So, right. So if you do that, it will only show traffic that is actually coming and going from me to and to me, right? So either as source or destination. So we see complete protocols. Is there anything interesting in there? Well, it's mostly the stream and acknowledgements of receipt. So yeah, mostly streaming. It's probably pretty hard to find any other meaningful HTTP. See if I find some HTTP only communication. Oh, it's scrolling through. Oops, nothing. So if I look for particular protocols, it's pretty hard. So my machine is not a good example right now because it's pretty busy doing other things. But still filter for your own address. Instead, I will show you. I'll show you a dump that I collected earlier. It's probably a bit safer. Continue without saving. And I would hope it's loading. Is it? No, it's not. Ah, there you go. Cool. So it was a collection of data I did a bit earlier. And what you see is basically my machine doing all kinds of things. So for example, if you browse through here, I bring a magnifier back up, even though it's not super helpful for me here. So hang on. So. You see all kind of information, such as the timestamp, of course, it's sent, source and destination IP address, and also the protocol. So here, most of the protocol information is already resolved to its name, because again, also Wireshark, of course, knows about the protocol conventions there and does most of the heavy lifting for you. So what we have here is, what is that most likely? Yeah, and what does it do? As a recollection?
Asks for an IP address.
It asks for an IP address, that's right. That's right. I lost it there. So, okay, it asks for an IP address. So what you have then there, so let's explore that. On the lower level is the detail pane. And it literally allows you to scroll through all those protocol headers that we just discussed, starting with the frame. It tells you, okay, what interface ID am I listening on? What is the encapsulated information? Well, it's Ethernet. It knows that. Identified based on this preamble I showed you earlier. Frame numbers, the size, and a lot of information you don't really need to worry about. Next higher level. Okay, let's look at the actual Ethernet package. And if you guys recall from before, what were the important fields in the Ethernet package? Please. Addresses? What addresses appear in the Ethernet package? Yeah, the hardware addresses, right? So when you find them precisely here, if you look here, there's something like Cisco 9F and then Intel Core 4D. And here, Wireshark again goes a bit further. It even knows the manufacturers of the devices that are communicate because the prefix is vendor specific. Only the suffix, the last few bits, are specific to your device as a unique identifier, right? So that in the parentheses you see the full MAC address, but here's the abbreviation. So we know on Ethernet level we're having a Cisco device, an internet device that are communicating, Intel device that are communicating. The next higher protocol is IPv4, so we can dig in here and look into that one as well and see the source and destination address. And a pointer, most important, for the next higher protocol again, which happens to be UDP, and then we can look into this UDP protocol, which is very simple. What's the source port? What's the destination port? And based on the destination port 53 now, we know, oh, okay, it must be a DNS package, right? So, because that's in that list. And then you find the actual content up here as application data. And the actual content is quite straightforward. It actually says, okay, please resolve that following name. So wpet.it.ntnu. It wants to do some automatic configuration, so it asks for that one. That's the query you get. And again, Wireshark is quite clever. It also knows what the response is. If it links you to the response package, with this package 47. See if we find this one here. So standard query response, right? So it's pointed out here. And then we see, okay, what's actually coming back from the domain name system. No such name, right? So it says, based on flags that are specific to the DNS protocol, it says, well, you know, I couldn't find that name, bad luck, nothing, you know, I can't resolve it for you, for example, right? So this is the idea here. Basically, you can dig into the whole protocol and also link up streams of conversation. So hang on. It will try, it's not too helpful. See if I find some HTTP style information here. No. It allows you to identify packages that belong together, right? So I mentioned before that TCP splits up packages into multiple chunks and parts, and you can follow that interaction, but also retrace what has happened using the follow TCP stream tool. For example, here there's a request going to port 80 from this local machine, and there's a response from port 80 to my local port, and then there's some data that is transmitted in the course of it, whatever it actually contains. And at the end, there's a finalization of the interaction. So the session is terminated. It's a good way of keeping track of potential HTTP interactions that you would do. And that's what I want you guys to kind of figure out. I gave you an example trace that you can later use, and there's, as a bit of a quiz, there's a HTTP interaction in there, and I want you to figure out what data is transmitted and what the content of it is in particular. One thing that's useful for you to use is look at the statistics and check the protocol hierarchy. It actually gives you, once you sniff a bit on your network, a better understanding of what's actually going over your wire in terms of protocols. So if, for example, we can easily see here that everything that goes over the wire is Ethernet. Nothing else is happening here. And around 70% of that is IPv4, so the internet protocol that I used before. There's a new one, IPv6. We didn't talk about it, so ignore it for now. It's about 1/3. And of this IPv4 traffic, around 60% is transmission control protocol, and most of it related to NetBIOS and SMB2. So SMB2 is for file transfer and local networks, so you don't need to worry about. But it's a good way of breaking down what kind of traffic you have in a network and what it relates to. So worthwhile having that tool, and sometimes just to look what's happening on your system. Is there anything else I need to add, Björn? No. Enough talking. Good. Right, so that's the idea, right? So you install Wireshark, don't only listen to your own stuff. Download this trace. You can open this in Wireshark using file open, have a look at it. Important to set if you want to listen on a network, set the correct network interface. Don't listen on your Bluetooth interface if you don't use it, because there will be next to no traffic. So use it, for example, Wi-Fi, where you actually interact. Filter your own IP address using the string like IP.address equals and then your IP address, which you figure out using ipconfig in the Windows case or ifconfig in the Linux case. And then start exploring some of the interactions that are actually going on there. And with respect to the file, try those following things. Find the file download via HTTP. What's the file name and the content? Do we see any other HTTP interactions? Any UDP interactions? And explore the distribution of TCP and UDP on your machine as well. So I hope that gives you a better understanding into the layered system. So I encourage you to work your way through it, and it kind of entrenches a bit of what we have talked about, because there was a lot of talking from my side. Questions? So far, so not? Okay. So you can, since the files are available for download, you can also, of course, do it at home and do it there. But also, of course, listen on your home network. That's something that's probably a bit more legal, since you most likely control it. So then you can actually see what traffic is going on, right? So, for example, if you have smart home devices, what are actually sending over the wire, right? So what do they send back to Google or Amazon or what other vendor you're using? So it's a worthwhile tool to play around with and at the same time explore the different layers. Try to be consciously exploring Ethernet, IP layer, TCP, UDP, and application data. Cool. Yep, I'll put the slides online, and then you guys can do it on your own.
Did I find the right user?
Yeah, I would prefer if you leave that challenge open, and we'll answer it next time.